Hello friends, welcome to our channel. Let's have a look at today's daily challenge problem. Problem 1752. Check if array is sorted and rotated. This is an easy problem, but it's very interesting. So here, given an array called nums, return true if the array was originally sorted in non-decreasing order, and then rotated some number of positions, including 0. Otherwise, we return false. And here, there might be duplicates in the original array. So if you look at the three examples, the first one is true. It's very easy to observe, right? So because originally it's 1, 2, 3, 4, 5, and then you just shift, right? So here in example 2, it's impossible because here 2 is less than 1 and 3 is greater than 1. So the third example is very special because it's already in strictly increasing order, so it's also true. And the problem size is small because the length of this list is bounded above by 100. So we saw some solutions for this problem. I feel that the solutions are complicated. So here, let's see how to be a valid rotated array in the sense of this problem. So actually, we can consider the two items here. First, so we expect at most one inverse order, right? If you look at example 1, so this 1 is less than 5. But if you look at it here, so this is the 1. But it's a bit, it's not 1 is less than 2. But here it's not. You cannot. So here the 4 is greater than 2. Right. So in the third example, it's the 0 reverse order. So the second item is that if the reverse order is 0, so it's already valid because it's corresponding to a increasing one. Otherwise, if the inverse order is 1, we just need to check if the last element is less than or equal to the first element. So here it should be less than or equal to. The reason is that there might be duplicates in the original array. So with that said, I guess it's very straightforward to convert these comments into coding format. Let me write with some redundancy. So here, this n is just for convenience. Let me first consider a special case or edge case. If n is less than, I would say, less than 3, that would be still bigger. If you have at most 2. It's either already sorted or just reversed. So we can always return true. So then let's introduce the inverse flag variable. It's a counting variable. So then we just iterate over this array or list. So for I in range 1 to n. So here I start the index from 1. The reason is that I want to compare with the previous one. So you can also start from 0 and write the second argument as n minus 1. So this way you can compare with the next one, right? So first, if nums I is less than nums I minus 1. So this means that we have a inverse order. So we're going to increment this one by 1. So next, we just need to prepare the return. First, if inverse flag is greater than 1. So here I would say it might be used an inverse count. That might be better. So flag, basically, most of the time I prefer to use it as a boolean. Anyway, let's keep it here. So if this inverse flag is greater than 1, so we just return false. Otherwise, so if the inverse flag is 0, so if you look at example 3, then you need to return true. Other case, the inverse flag will be 1. Then let's look at example 1. So we just need to, the last element is less than or equal to the first one. So return nums negative 1 is less than or equal to nums 0, right? So less than or equal to is due to the assumption that there might be duplicates in the original array. So with that said, I guess that's the full coding for this problem. Let's do a quick check. Yeah, it passes all the 3 test cases. Now let's look at the generic case. It passes all the cases. Yeah, I would say that's basically about it for the current video. Thank you for watching.